Hello everyone, welcome to chemistry. This is Dr. Rhonda Cofield and this is my 2023 edition of the videos for Chem 1. We are going to be using the Burge textbook for these sessions. The sections that we're covering are all of them 1.1 through 1.6. Those will be different depending on the chapter, and I'll always let you know which sections we're actually looking at. These are your learning objectives. These are what you are expected to know how to do by section before we finish the chapter. So this is part 1, your first video of chemistry. So in this section, we're going to define chemistry, and we're going to identify key components of the scientific method. We're also going to do section 1.2, which we're then going to talk a little bit about classification of matter. So chemistry is the study of matter, but it's also the study of the changes that matter undergoes. So matter is everywhere. It's what makes up everything. It's anything that can occupy mass and space. Okay, so it has mass and it occupies space. And although there are different types of matter, the various combinations of atoms of a relatively small number of these simple substances are called elements. And the number varies because they are all the time discovering new things. But all the naturally forming elements have been identified. The properties of matter depend on what these elements contain and how the atoms are arranged in and around the nucleus of that atom. And these are just a few examples, common examples that you may have seen in your everyday life. Rust, we all see the rusty old pickups in the back 40 or whatever, but you will find rust is a chemical reaction between iron and oxygen. And so that's why we paint our cars, because that keeps the oxygen from getting to the iron. And then fizzy stuff, that's always a great indication that there is a chemical reaction going on. And so if you see bubbles, that typically means that you're doing something to change from one to another. And in the case of creme brulee, yum yum, you can change the molecules by actually heating them and breaking bonds using that heat and converting those into other substances. So a little bit about the scientific method, and you use this all the time, whether you know it or not. Whenever you're wondering if something is working, why is it not working, what can I do to make it work? That's the scientific method, and you, by trial and error, sometimes are finding ways to do this. So first of all, in the scientific method, you make observations. And this could be things that you see in nature. It could be things you see in a lab. It may be something that everyone has seen over and over again, like gravity, for example. And so it's considered a law because everybody recognizes it's always going to do the same thing. If it's not a law and you're going to see if you can figure something out about it, you will form a hypothesis. A hypothesis is a tentative explanation, like it says here, a guess about, educated guess, we should say, about what's going on. And how would that explain what you are seeing? And then you make experiments, okay? You form procedures to test your hypothesis and measure one variable at a time so you can see what's actually making this happen. And then once you've done that, you do a theory. And if the things support your hypothesis, then you can come up with a theory that can predict what will happen the next time this occurs, okay? But if it doesn't really support that, you need to do further experimentation, and that further experimentation goes back to that. You may have to change your hypothesis a little bit, and then do more experiments and form a new theory. if it works. If it doesn't, you're going to repeat that. So that's why it's kind of like a cycle. And so that's what the scientific method is all about. So we're talking about matter, and we're going to look at some classifications of matter. We can do that by the state it's in, gas, solid, liquid, whether it's a mixture of things, and is it heterogeneous or homogeneous. And then we're going to figure out what is actually going on with this. And so that's what chemistry, I think of chemistry as a central science because it explains so much of the world that's going around us. So first of all, the three physical states of matter that we're going to look at in this class are solid, liquid, and gas. And how these are different from each other, I'm going to show you a little picture here in a minute, are how the atoms are packed and whether or not it is got its own shape or it can take on the shape of a container. And so each of these is different by what that means. So in the case of a solid, if you look at the solid, you've got these closely packed molecules, okay, atoms. And those atoms are in a nice little geometric pattern, okay? And so they're very, very tightly packed. And when they're tightly packed like that, they're going to keep their own shape. So they're going to have a fixed shape and a fixed volume. So if I pick that up out of there, if I could, and I put it in another container, then that is going to always, it's going to have the same shape. It's not going to change the shape to it. In a liquid, the atoms are still very, very close together, but there's a little bit of room in between them, if you see, so that they can kind of move between each other. And so there's a little bit of movement that can go on with the liquid, more so than the solid. If you put a liquid in a container, it will take on the shape of that container, okay? And so it has a fixed volume, but not a fixed shape. So its shape can be variable. And then in the case of a gas, notice how far apart these molecules are, okay? And so they're bouncing around off of each other, off the sides of their containers, and they are going to not have a fixed shape and not have a fixed volume because they can actually take up the entire volume of a container. So chemists classify matter as either a substance or a mixture of substances. So a substance is a specific composition and has distinct properties of matter. So it will always be the same, okay, if you see this substance. And it could be iron, which is an element, or it could be sodium chloride, which is a compound. So elements are substances that can not undergo any further change, whereas compounds are going to be elements put together chemically that can. And different substances are going to be different from one another based on their composition and their properties. And properties could be like how they look, how they smell, how they taste, or other things. So as I said, an element is a substance that can't be separated chemically into simpler things. So it's as simple as it's going to get. And it could either be a single atom as an element, for example, neon, or it could be something that is in a gas form that is found in nature hooked to itself, okay? And so that binary situation, such as hydrogen gas, it exists as H2, so its elemental form is H2. Compounds are going to be where you have combined elements together, and it's going to be chemically united or bonded. We'll see later is how we really say that. And you cannot separate it into simpler substances by physical processes, which means you can separate it chemically, but you can't separate it physically. Physically would be like filtering and stuff like that. So a mixture is a combination of two or more substances, so they could be elements or they could be compounds, in which the substances retain their identities. So notice in this example, I have different things in this mixture, but they're not combining chemically to become something else. They're still maintaining their own distinct identity. So pure substances, mixtures can also be solids, liquids, or gases, okay? So mixtures can either be homogeneous or heterogeneous. Homogeneous means they're having the same composition throughout, whereas heterogeneous, they have a variable composition. So you could see different things depending on where you took a sample. Okay, so heterogeneous mixture is like if you mix sand and iron filings together, and you can't really get an exact mixture together. Like they're going to be different if you like pulled a sample from different places. So just to clarify, you have matter, which occupies space and has mass. It can either be a mixture, or it could be a substance, and you could separate a mixture physically into a substance. Mixtures are going to be either homogeneous or heterogeneous, depending on if they have the same or uniform property throughout, or whether they're going to be hetero, which means they're going to have a different composition in that mixture. Substances can either be compounds or elements, and elements actually form the compounds, right? They're made up of elements. And compounds can be separated by chemical means into their components, which are the elements. So if that's making your eyes roll back in your head, stop this, go back and go through it again, because this is very important that you understand how we're classifying these things, okay? So just to kind of test where we are, let's look at some examples. This is a piece of copper, okay? It is just copper, therefore it is an element, right? Which means it's a substance, because an element is a type of substance. This is a mixture. Looks like trail mix. Makes me hungry. This is a heterogeneous mixture, because if I put my hand in that bag of trail mix, each time my hand pulls out a sample of it, it could have a different number of raisins or nuts or whatever. So it's going to be different every time. Seawater is also a heterogeneous mixture, because if you take a sample of this seawater, depending on how close you are to the shore, it might have sand in it. If it's farther out to sea, it might have less things. It could have algae, it could have fish, it could have plants. So it's going to be different no matter where you take a sample of it. This is a heterogeneous mixture, and that one's pretty easy to figure out because you got oil and water. And even if we shook that and shook it, it would still separate into two things. So it would be a mixture, a heterogeneous mixture, right? And then these that are compounds are substances, okay? And they are, though, compounds, right? So the compounds are made up of elements, but we could apply some chemical razzle-dazzle to those, and the compounds, we could go ahead and split them into their components. So that's why they're a compound rather than an element, which can't be split into anything simpler. So that is it for classification of matter and for your little introduction into chemistry. And I hope that you will join me for the second part of this, where we're going to start looking at the scientific measurement. So stay tuned.